on guys, let's do this problem right here. The question is asking 125 joule of heat flows into the system and 45 joules of work is done by the system as it moves from ADC. The 30 joule of work is done by the system in path ABC. How much heat energy is absorbed in path ABC? So let's see how we can do this. But before that, we have to note an equation down. This is going to be the main equation in most of the questions. So that is delta U is equal to Q minus W. So this is the equation we are going to use most of the time. So let's note this one aside, and let's deal with the first problem. So let's note down the given information. So they are saying 124 joule of heat flows into the system. So whenever we have heat flows into the system, that's positive. So Q here is positive 125 joule, right? And then 45 joules of work done by the system. If work is done by the system, that's positive. Positive 45 joule, right? Now let's see. Done by the system as it moves from ADC. So this is the path ADC, right? If you note down the graph, it's going from here to here, right? This path. So that is this, and let's look at the other one. 30 joule of work done by the system in path ABC. So we have ABC done by the system is positive. W is equal to plus 30 joule, right? Plus 30 joule. And they are asking how much heat energy is absorbed in path ABC. So they are asking for Q right here. What is the Q? That's the question. So here we have plus, right? Here we have these two things right here. Here we have this thing. To find the Q, you know this equation. To find the Q, we have to use Q is equal to delta U plus W. But here we only have W. We don't have the delta U, right? But for this one, we can calculate the delta U. The thing is, delta U, like if you move from here to here or here to here, like it doesn't depend. So delta U doesn't depend on the path. It just depends on the final distance, right? ADC, you will get the same delta U. ABC, you will get the same delta U. Or if you go through this, it's going to be same delta U. So it doesn't depend on the path, independent of the path, right? So if I calculate the delta U for this one, ADC, that's going to be same as ABC because both are going from A to C. So let's calculate this delta U and find the answer. So delta U is going to be Q minus W, right? Here we have Q and also we have the W. So all we have to do is simply subtract W from the Q, and that's going to give us 80, right? So this comes out to be 80 joule. So if this one is 80, this is also 80. Here also we have delta U that is equal to 80 joule. If we know the delta U, we can find the Q. Q is equal to delta U plus W. 80 plus 30, that's going to be equal to, so the answer for the first one is going to be 110 joule. So that's going to be the answer. Okay, so we are done with the first question. Let's look at the second question. When the system returns from C to A along the curved path, so it's going from C to A, 38 joule of energy transferred by work. How much heat energy is transferred during the process? So let's say this is our first A part, right? This is A part, and let's do the B part. So B part, they are saying, so this one is going from here to here. So we know that from here to here, A to C, the delta U was 80, right? To go from A to C. If it's going from C to A, what's going to be the delta U is 80. If it's going from C to A, what's going to be the delta U? It's going to be opposite sign, like negative. So here we are going to get delta U that is equal to negative 80 joule. Also, if you have a work going from opposite, like whenever you have anything going in this direction, like from right to left, that's always negative. So here, if the work goes from here to here, that's going to be negative too. So here, this 38 joule, that's going to be a negative value. So here, W is going to be negative 38 joule, and they are asking for the heat energy. So they are asking for the Q. We are going to use the same equation. Q is equal to delta U plus W, negative 80 plus minus 38, and that's going to give us negative 118 joule. So this is going to be the Q. And let's look at the other question. So this is the answer for the next part. Let's look at the other question. So we have B part and we have another part in the B part. How much heat energy is, oh, this is B part, and let's look at the other one. This is the one we done already, right? If U A is equal to 0, so they are saying this is equal to 0, and UB is equal to 20 joule. UB is equal to 20 joule. How much energy is absorbed in the path AB? So let's do it. So let's say this is B1, AB. So they are asking about AB. We are trying to find Q, right? How much heat energy is absorbed by the path AB and BC. So let's do the AB first. To find the Q, we know that we need delta U and W. A to B. So we know that A to B to C, the work is this much, 30 joule, right? 30 joule. And one thing, whenever you have a vertical line, this is an isochoric process because the volume is same. So here, whenever you have a vertical line, work is always 0. If the volume is equal, constant, work is always 0. Here also work is equal to 0. Right? So AD's work is equal to 0, BC's work is equal to 0. So we know that the W ABC is going to be equal to WAB plus WBC. Right? So this is going to be the equation, because if you add these two work together, that should give us the total work. We know that the BC is going to be 0 because since the volume is constant, the work is 0 at BC. So this is 0. We know that AB is 0, AB is 30 joule. Therefore, WAB is going to be also 30 joule because WAB plus 0, 0 does nothing. WAB is going to be equal to 30 joule. So we know that work at AB is going to be 30 joule, right? Work is 30 joule, and delta U is going to be final minus initial. So final is 20 joule, that's provided in the question. So they have given UB is 20, UA is 0. So B is 20, so B minus A, that's going to be 20 minus 0, that's going to be 20. So we have U and W. Now we can calculate the Q. Q is going to be equal to delta U plus W. So here we have 20 plus 30, that's going to be 50 joule. Right? So we have this one right here. Let's see what this. Then they are asking for the BC right here. So let's see how we can find that one. BC, right? So they are asking for the Q at BC. Do we know the W? W is 0, right? Q, W is 0 because we know the volume is constant. So this is, whenever we have vertical line in a PV diagram, that's always 0. So this is 0. We had to know the delta U. And in the previous question, if you notice that one, A, B, C path right here, we know that to go from A to C, it was 80 joule. And here we know that A is 0, right? So if it's A to C is 80 joule, we know that final minus initial give us the total delta U, right? So if this is 0, 80 minus 0 should give us the 80. So we know that this is at C, it's 80. U is going to be 80. So if U is 80 at C, what is going to be at BC? BC is going to be final minus initial. Final is 80 minus initial, that's 20. 80 minus 20 is going to be 60. So here we are going to have delta G that is equal to 60. If delta G is 60, we can calculate Q, because Q is equal to delta U plus W. Therefore Q is also going to be 60. So here we get Q. So let's say this QAB and QBC is equal to 60 joule, right? And here this one was what is that? This one was QAB, QCA. This is QCA and this is QABC, right? QABC. Okay, so we are done with this part right here. Let's look at the last part. If joule D is equal to 30 joule, so they are giving this one. This one is equal to 30 joule right here. 30 joule. How much heat transferred from path AD to AD and DC? So now let's do. This is what B2, right? B2, and first we are going to deal with AD. Here also we are trying to find the Q. We need to know W and delta U. So here, do we have the W? A to D. A to D, we know that's 0 because this is a vertical line. Whenever we have a vertical line in PV diagram, that's always 0. So here work is equal to 0. Work is equal to 0. Do we have delta G? Delta G is going to be the difference, right? So we are dealing with AD, D minus A, 30 minus 0, that's going to be 30. Okay, so we have W, delta G, we can calculate the Q. Q is going to be delta G plus W, therefore Q is going to be, QAD is going to be equal to 30 joule. So let's deal with the next one, that is DC. DC, right? We are trying to find Q, we need to know the W. DC, do we have the W? ADC is equal to ADC equal to 45 joule, right? ADC is equal to 45 joule. So we know that WADC is equal to WAD plus WDC, right? If WAD is equal to 0, we know that this is a vertical line, 0, right? Therefore WDC should be equal to WADC. We know that WADC is 45. So this one must be 45. WDC must be 45. So W here is going to be 45 joule and delta G DC. We know that at D is 30, at C is 80. 80 minus 30, that's going to be 50. So here we have delta G, that is equal to 50 joule, and we are trying to find Q, right? So Q is going to be delta G plus W, that's going to give us 95. So Q DC is equal to 95 joule, and that's going to be the final answer. And that's all they are asking, right? And I hope you guys find this video helpful. Thanks for watching.